Hello students, welcome to your channel Learning Point. Today we are going to study exercise 3.5 of the parametric functions, which is a part of new syllabus of 12th commerce. So the first question that is given to us is something like this: x is equal to 80 square and y is equal to 280. So we observe over here that x is a function of t and y is also a function of t. So we have to differentiate x with respect to t, differentiate y with respect to t, and then we will divide both the derivatives so that we get our required value of dy by dx. Question is as usual to find dy by dx. Guys, I am starting with the exercise over here, but I have also provided the link of the basics of parametric function and some examples of the parametric function in the description box. As well as you can see at the top right corner, you will get a link over there. So if you wish to understand parametric functions more properly and in detail, I would suggest you that just reach out that link and you would be able to understand that very nicely, I'm sure. Let us continue with this sum, guys. It says differentiate with respect to t. In fact, we should say differentiate x with respect to t first. So I will get derivative of x dx upon dt, which is equal to a over here is the coefficient, so we cannot do anything with this a, but derivative of t square will be equal to 2t. So I get the value as 280. Give it as equation 1. Similarly, differentiate y with respect to t. So derivative of y, as you all know, it is dy by dt, which is equal to 2a is the coefficient, so we leave this 2a as it is. And when we want to find the derivative of t, I get over here derivative of t is same as derivative of x, which is equal to 1. So I get 2a into 1, which is equal to 2a. Give it as equation 2. Now guys, I have to find the value of dy by dx. So what we do over here is we have to write divide equation 2 by equation 1. So I get dy by dt upon dx by dt, that is 2a divided by 2at. We cancel off the values dt and dt as well as 2a and 2a. So we are left with 1 in the numerator, and hence our answer over here is dy by dx is equal to 1 by t. So students, it's a very simple sum number 1 of your exercise 3.5. Let us see the question 2. It says x is equal to 2at square and y is equal to a into t to the power 4. So once again the question remains the same. We have to find out the value of dy by dx. So I will first of all start with differentiating x with respect to t. So derivative of x is dx upon dt, and on the right hand side we leave this 2a as it is because it is the coefficient. derivative of t square is similar to the derivative of x square. Derivative of x square is 2x. So for t square, it is going to be 2t. So finally, I get the answer as 4at. That is your equation number 1, guys. Now we say differentiating y with respect to t. So derivative of y is dy upon dt. Now when we are differentiating y, we observe that a over there is a coefficient. So we write this a as it is. Derivative of t raised to 4 is similar to actually x raised to 4. Comparing this with the formula for x raised to n. The answer is n into x to the power n minus 1. And considering that value of n over here is 4, I will get the answer for t raised to 4 as 4 into t raised to 4 minus 1, which is equal to 4 into t raised to 3. Guys, this is covered up in the basics of the differentiation chapter. You can see the link at the top right corner. So please check out that link whenever you wish to study the basics of your differentiation topic. So this over here becomes 4at cube. Equation 2. As you all know, guys, we are interested in the value of dy by dx. So once again, we have to say over here, divide equation 2 by equation 1. So you get dy by dt upon dx by dt is equal to. Now what is dy by dt? It is 4at raised to 3. What is dx by dt? It is 4at. So students, dt and dt will get cancelled off. 4a and 4a will also get cancelled off. And we are left with the power 2. And therefore, my final answer comes out to be over here. Dy by dx is equal to t to the power 2. So that is the answer for your sum number 2 of question 1. Now let us understand sum number 3, guys. You are having a very simple question. X is equal to e to the power 3t and y is equal to e to the power 4t plus 5. Now we observe over here that x and y, they both are expressed in terms of t once again. So I have to use over here the derivative with respect to t. Now this is e raised to 3t and this is e raised to 4t plus 5. They both are actually expressed in terms of e to the power fx. What is the formula for e raised to fx? It is e raised to fx multiplied by derivative of fx. Students, this is a part of composite functions. I have given the link of composite functions in the top right corner. Kindly check out the link so that you understand all the types of composite functions in a better way. So when we differentiate this, I have to write over here differentiate x with respect to what? With respect to t, guys, because the variable is t. So dx by dt is equal to e to the power 3t multiplied by derivative of 3t like we did in the given formula. So I get this is equal to multiplied by 3 because derivative of t is equal to 1. So the answer is 3 into e raised to 3t. We consider this is our equation 1. Similar manner, we say over here differentiate y with respect to t. So I get over here dy by dt. So when we want to find the value of dy by dt, we have to differentiate e to the power 40 plus 5 e raised to fx. So I will write over here e raised to multiplied by derivative of 40 plus 5. So this e raised to 40 plus 5 is as it is, and derivative of 4 into t, that is 4 into 1, derivative of 5 is 0, so you just get 4 into t. So we get this is equal to 4e to the power 40 plus 5. Equation 2. Once again students, we are interested in the value of dy by dx. So again we have to write over here divide equation 2 by equation 1. So you will get over here dy by dt upon dx by dt. What is dy by dt? 4 into e to the power 40 plus 5 upon 3 into e to the power 3t. So students, over here dt and dt will get cancelled off. Here I get this as dy by dx, and 4 by 3 over there remains as it is. But for this term I have to apply my law of indices, a raised to m upon a raised to n is equal to a raised to m minus n. So the numerator 40 plus 5, this is the value of m, and this over here is the value of n. So you will get 40 plus 5 minus 3t. So when we simplify, I get 4 upon 3 e to the power t plus 5 dy by dx. So students, that is your answer for question number, sum number 3 of question 1. Now let us check out the question number 2. Again in question number 2 it remains the same, to find dy by dx. Sum number 1 over there says x is equal to u plus 1 by u the whole square, and y is equal to 2 to the power u plus 1 by u. Now we consider, or we observe in fact, that x is a function of u, y is also a function of u. So we have to say over here differentiate x with respect to u. So what is derivative of x with respect to u? Dx upon du. So you get the value as derivative of this function is taken with the help of composite function, which is fx to the power n, which is n into fx to the power n minus 1 multiplied by derivative of fx. I consider entire bracket u plus 1 by u is your fx. Therefore 2 into u plus 1 by u to the power 2 minus 1, which is just 1, multiplied by derivative of u plus 1 by u. Now this remains over there as it is. Derivative of u is 1. Derivative of 1 by u is actually minus 1 by u square. So you get 2 u plus 1 by u multiplied by 1 minus 1 by u square. Now students, there is a small catch, some small simplification required in this particular sum. So please understand, you are given over here that x is equal to u plus 1 by u the whole square. So I can say that root of x is equal to u plus 1 by u. So this has to be substituted over here in this term in fact. So you will get this is equal to 2 root x, and we leave this 1 minus 1 by u square as it is for now, and this becomes your equation 1. Now what is x? It is 2 to the power u plus 1 by u. So we'll write not x, in fact y, and I will now differentiate this with respect to x. With respect to u. So I will get over here dy by du. As I told you in the beginning, this is again in the form of a raised to fx, and the derivative of a raised to fx is a raised to fx into log a into d by dx of f of x. So this is equal to 2 raised to u plus 1 by u into log 2 into derivative of u plus 1 by u, which is equal to, now students, if you observe very clearly, 2 raised to 1 by u plus 1 by u is itself the value of y. So in place of this, I will just replace this by y, and the remaining terms will be as it is. Log 2, and derivative of this term, derivative of u is 1, derivative of this is minus 1 upon u square. So you get the answer as y log 2 into 1 minus 1 by u square. This becomes dy by du, equation 2. We are over here interested in the value of dy by dx. So as we used to do in the previous cases, we will say over here divide equation 2 by equation 1. So you will get over here dy by du upon dx by du. So this is y log 2 into 1 minus 1 by u square. Let us check out what was derivative of dx by du over there. 2 root x into 1 minus 1 by u square. Oh, that's great. So I can see here that the entire bracket element is going to get cancelled off, as well as du and du will get cancelled. So we get our answer dy by dx is equal to y log 2 upon 2 root x. So that was your sum number 1 of question number 2. Let us check out question number 2, guys. Question number 2 says x is equal to under root of 1 plus u square and y is equal to log of 1 plus u square. So when I want to differentiate this, I have to say differentiate x with respect to what? Can you guess? X is expressed in terms of u. So guys, you guessed it right. We have to differentiate x with respect to u. So left hand side will become dx by du, and on the right hand side you have to use the formula for root of fx. What is the derivative of root fx? It is 1 upon 2 root fx multiplied by derivative of fx, in fact, not root fx. I will write over here. So yes guys, fx is entire 1 plus u square. So I get 1 upon 2 root 1 plus u square into derivative of 1 plus u square. So this 1 upon 2 plus under root 1 plus u square, it remains as it is. And what about this? Derivative of 1 over here is 0. Derivative of u square is 2 into u. So I get over here 2 into u. Now I can see the elements 2 and 2 getting cancelled off. So you are left out over here with u divided by. What is this root of 1 plus u square? Guys, you can see it is actual value of x. So I get this value as u upon x. And I give it as equation number 1. Then we get over here. Let me take down that y element once again. It was log of 1 plus u square. And now I will say differentiating y with respect to u. So what do we get? Dy by du, and that is equal to log of 1 plus u square. It is in the form of log of fx, and the derivative of this is 1 upon fx multiplied by derivative of fx. So this over here becomes 1 upon 1 plus u square multiplied by derivative of 1 plus u square. So now this 1 upon 1 plus u square is outside the derivative sign. So we leave it as it is. And this element over here, it is 0 plus 2u. So you get the answer as 2u upon 1 plus u square. This is your equation 2 dy upon du. Now guys, because we are interested in calculation of dy by dx, again we will say divide equation 2 by equation 1. So it is dy by du upon dx by du. So what is dy by du? It is 2u upon 1 plus u square. What is dx by du? It is u upon x. So guys, over here du and du element will get cancelled. U and u element will get cancelled. So I will get over here dy by dx is going to be equal to this x element will go in the numerator and it will become reciprocal. So the answer that comes over here is actually 2x upon 1 plus u square. Now, how do we simplify this? How do I write my final answer? What I will do is, I will write over here 2 into root of 1 plus u square upon 1 plus u square. Now there is a very important law of indices that we have studied in the indices part is root of a multiplied by root of a is actually a. So suppose if I want to find out the value of root of a upon a, it will become just 1 upon root a. So therefore if I compare this with my given indices law, I will get the answer over here as 2 upon under root of 1 plus u square, and I consider that a is equal to 1 plus u square. This is just for your understanding, guys. You don't need to show all these things in your exams. In your exam, you can just show this pink part. It is sufficient for your examiner to give you the entire marks. dy by dx is equal to 2 upon under root of 1 plus u square. So students, that was your question number 2. Now let us understand our question number 3. It says differentiate 5 to the power x with respect to log x. I took a similar example in my previous video. On the right hand corner, guys, you can see the link over there. You can check out to see the previous example also. Once again, I'll explain what happens over here. When I differentiate 5 raised to x with respect to log x, I have to assume the first term as u and the second term I assume as v. So basically, question is to differentiate u with respect to v, and you are expected to give the value of du by dv. So let's begin, guys. Let us see how to solve this. It's a very basic sum and a very easy sum. I assume let u is equal to 5 raised to x and v is equal to log x. Once again, u is a function of x, v is also a function of x. Therefore, we say that these are parametric functions and I have to differentiate u and v both with respect to x. So let us see how. Differentiate u with respect to x. Derivative of u is equal to du by dx, and this term over here is actually in the form of a raised to x. The derivative of a raised to x is a raised to x into log of a, With considering that a is phi, answer is going to be phi raised to x into log phi. Nothing further can be simplified, so I consider this as my equation 1. Then I will say differentiate v with respect to x. So I get dv upon dx. Derivative of log x is just 1 upon x. That is our equation 2. But we are interested in finding the value of du by dv. So what we do is, here I will say divide equation 1 by equation 2. So when I divide equation 1 by equation 2, what do we get? Du by dx is equal to 5 raised to x into log phi divided by 1 by x. Cancel off these x elements, guys, and this 1 by x becomes reciprocal. So the answer that I will get over here is du by dv is equal to x into 5 raised to x into log phi. So guys, that is our answer for the sum number 3. I'm sure this is very easy for everybody to apply and understand. Now let us see question number 3, the last question of this particular exercise, but that is based on proving of certain points, certain things. So let us understand how we will be proving those particular sums. Question 3. And sum number 1. See, you are told x is equal to a into 1 minus 1 by t, y is equal to a into 1 plus 1 by t. We have to prove that dy by dx is equal to minus 1. So when we want to prove this, let us start with differentiating x with respect to t, because x is expressed in terms of t. Here there are two letters a and t, but we observe that a is just multiplied outside, but the function is actually in terms of t. So you have to be careful that you have to differentiate with respect to t and not differentiate with respect to x. So when I differentiate this with respect to t, I get dx upon dt is equal to, as I told you in the beginning, a is the coefficient, we cannot do anything with that. Derivative of 1 is equal to 0 minus derivative of 1 by t is actually minus 1 by t square. This is similar to 1 by x, whose derivative was minus 1 by x square. So I get the answer as a upon t square. Minus and minus is plus. A gets multiplied with 1, so a, and denominator is t square. This is your equation 1. Then so what is y over here? A into a plus 1 by t. Let us see. Dy by dt A is again the coefficient, we cannot do anything with that. Inside the bracket, derivative of 1 is 0 plus negative 1 by t square. So now when I open this bracket, I will get minus A upon t square. That is our equation 2 for value of dy by dt. And this of course is our value of dx by dt. So students, when we want to find the value of dy by dx, you all very well know we have to divide equation 2 by equation 1 upon, so what is the value of this and what is the value of equation 1? Wow, dt goes away, a upon t square goes away, and you are there with your answer. It is equal to minus 1. Hence proved. That was a really simple sum. Now let us see question number 2. It says that x is equal to 4t upon 1 plus t square and y is equal to 3 bracket 1 minus t square upon 1 plus t square. We observe that x and y, they both are expressed in terms of t. So we have to differentiate both x and y with respect to t. Let's begin with x. Differentiating x with respect to t, you get derivative of x as dx by dt. Now guys, over here I have to use the division rule, u by v rule as we call it. So I'll write the rule for you over here. But if you want to understand the division rule in more detail, the link is provided in the top right corner. Please visit the link so that you understand the entire division rule as well as multiplication rule in a proper detailed manner. So the answer is v into du by dx minus u into dv by dx upon v square. So in such a case, 1 plus t square into derivative of 4t minus 4t into derivative of 1 plus t square and whole divided by v square, which is actually 1 plus t square the whole square. So now over here, this 1 plus t square, which is outside the derivative, comes down as it is. Derivative of 4t is 4 into 1, which is 4, minus 4t multiplied by derivative of 1 plus t square is 0 plus 2t, which is 2t. And again, whole divided by 1 plus t square the whole square. Students, you don't need to expand the denominator, you can just leave it as it is. Automatically, it will get simplified after some steps. Open the bracket. So it is 4 plus t square, in fact 4 plus 4t square minus 8t square divided by 1 plus t square the whole square. 4t square minus 8t square is 4 minus 4t square, and this is equal to 1 plus t square the whole square. Now students, this is a slightly important and a long sum, so please understand carefully. We take out 4 common. I get 1 minus t square upon 1 plus t square the whole square, which is split into two parts. 1 plus t square into 1 plus t square. Now why did we do it like this? If I observe my value for y, I can say from y that y upon 3 is equal to 1 minus t square upon 1 plus t square. If we substitute that over here, what do we get? 4 into y upon 3 into 1 upon 1 plus t square, which is equal to 4y upon 3 into 1 plus t square. Students, why are we doing like this? The reason is that we are asked to prove that dy by dx is equal to minus 9x upon 4y. So I require my answer in terms of x and y. Therefore, we have to express it in this manner. Okay? That becomes your equation 1. We have got it as dx upon dt. Now let me write the value of y for you once again, which is 3 times 1 minus t square upon 1 plus t square. So students, over here we have to differentiate y with respect to t. Derivative of y, as you all know, dy by dt. This 3 is the coefficient, so we won't do anything with that. And the bracket element, when we differentiate, you can observe carefully that again this is also u upon v rule. So like we did for the variable x, in the similar manner I will get 1 plus t square into derivative of 1 minus t square minus 1 minus t square into derivative of 1 plus t square and whole upon 1 plus t square the whole square. Once again students, this 3 remains as it is over here. 1 plus t square is outside the derivative sign. Derivative of 1 is 0. Derivative of t square is 2t. So 0 minus 2t is going to be minus 2t. Minus 1 minus t square, and in the bracket derivative of 1 is 0 and t square derivative is 2t. And I get whole upon 1 plus t square the whole square. Now guys, what we can do is I can take out this 2t common from both the terms, being careful with the minus signs over here there. This becomes minus 1 minus t square. This is minus 1 plus t square. 1 plus t square the whole square. So if you see that, guys, positive and negative t square elements will get cancelled off, and I will get minus 1 which is minus 2. So that is 3 into minus 4t divided by 1 plus t square the whole square. Minus 1 into minus 1 was minus 2 multiplied by 2, that gave me minus 4t. Now students, once again I have to adjust these terms a little bit because we require the answer in terms of x and y. So let us see the adjustment. This minus can be adjusted with 3 and the power is square. So what we do is we write it like this: 1 plus t square, one term over here, multiplied by 4t upon 1 plus t square. And what is this? If you observe your question, guys, this is your value of x. So it becomes minus 3x upon 1 plus t square dy by dt. And this is your equation 2. Now the last part, guys, because we are interested in dy by dx, what we have to do is equation 2 divided by equation 1. Divide equation 2 by equation 1. You will get over here dy by dt upon dx by dt. What is dy by dt? Minus 3x upon 1 plus t square. What was dx by dt? Let us check out, guys. 4y upon 3 into 1 plus t square. So over here, students, I can cancel off 1 plus t square and 1 plus t square as well as dt and dt. So we will be left with dy by dx and minus 3x into 3 upon 4y. Where did this 3 come from? This element over here gets reciprocal and is getting multiplied with the power numerator 3 over here. So students, you are ready with your answer. Dy by dx is equal to minus 9x upon 4y. Hence proved. Now let us see sub number 3 of question number 3. Sub number 3 says x is equal to t into log t and y is equal to t to the power t. So what do we get? We have to first of all differentiate this with respect to x, with respect to t in fact. We have to prove over here something. Let me write it for you. I have to prove that dy by dx minus y is equal to 0. So derivative of x, when we are finding, we have to consider this is u and this is v. Because the terms are multiplied, I have to apply the multiplication rule. I'll give you the multiplication rule. It is y is equal to u into v. So dy by dx is generally v du by dx plus u into derivative of v. So dx upon dt is equal to log t multiplied by derivative of t plus t multiplied by derivative of log t. So over here this becomes log t into 1 plus t into 1 by t. Cancel off the t and t values and you get the answer as log t plus 1. This is the value of dx upon dt. Let us give it as equation 1. We will see what further simplification needed to be done at the end when we want to prove the answer. So for now, I will write it over here as log t plus 1. When I want to differentiate y with respect to t, let me write y for you once again over here. T to the power t. Students, this is in the form of variable raised to variable, and therefore in order to simplify this, directly we cannot differentiate, but you have to take log over here on both sides. So when we take log, what do we get? Log y is equal to log of t to the power t, and as you know, the value of t in the power comes down behind the log because of the property of log, which becomes like this: t log t. I'll give you the property, guys. The property is like this: log of m raised to n is equal to n into log of m. So students, any further simplification is not possible. So now I will differentiate this with respect to x. Differentiating with respect to x, derivative of log y will be 1 by y into dy by dt. Sorry guys, I by mistakenly wrote this as x. You should write this as t. And over here, right hand side, once again we will apply the multiplication rule because u and v, they both are multiplied with each other. So it is log t into derivative of t plus t multiplied by derivative of log t. If you observe carefully guys, it is exactly similar to what you did for x. Now over here, because we are interested in dy by dt, we cross multiply this y over here and this becomes log t into 1 plus t into 1 upon t. So students, if you see carefully, this t and t element will get cancelled off. You get dy by dt is equal to y into log t plus 1. That's great. So now what is log t plus 1, students? Log t plus 1 is the value of dx by dt. So suppose if I say this is equation 2, and if we say substitute equation 1 in equation 2, I get dy by dt is equal to y multiplied by dx by dt. Now this dx by dt gets reciprocal and multiplied on the opposite side. So dy by dt multiplied by is equal to y. So students, you can cancel off dt and dt and you get dy by dx over here. Then subtract this y on the opposite side, it becomes minus y, and this is equal to 0. So students, that is your required answer. Hence, proved. Thanks for watching, guys.